Welcome, everybody. We're going to talk about physics engines today and have some fun with physics engines. We're super proud of our really nerdy title, 3D Physics for DOMies. And you know, this is my favorite conference to speak at. One, because it really helped start my company in a whole new direction when I spoke here last September. But I really love this conference because it brings together people that are working on HTML5, and we're all sort of battling on it to try to make it performant, or to make it beautiful, or to make it pleasant to work with from an engineering standpoint or from a designer standpoint. And each and every one of us that come up here speak are sort of tackling it from a different angle, and we share our stories with everybody to hopefully help everybody learn the lessons that we learned along the way. And that's what I hope to bring to you guys today, is really just bring the lessons learned from a pretty hard-fought journey that we've been on. And there's really two things that make us unique in the way that we're tackling HTML5. Number one, we believe that we can be equal to and even better than native. And the way we do that and the road that we need to take, we believe, is through DOM. And that is, we want to make the hardest thing work at 60 frames per second first, and then work with the easier things second. Canvas and WebGL are easier than working with DOM. And so we work and render in straight to DOM first with everything. The second thing that makes us unique is we are funded specifically to research the fundamentally hardest problems that exist in HTML5 and try to solve them. And right now we're working on 4 core engines. I've talked about one, the rendering engine, at the last HTML5 Dev Conference. Today I'm speaking about our physics engine. We also are building a gesture engine that controls all sorts of input, from mouse to keyboard to open-air gesturing systems to touch systems, and does that elegantly. And we're also building a 4th engine, which is a multi-screen engine, which allows you to flick to and from any device regardless of the OS, and you can flick all of or part of any app that you want. But today I'm here to talk about the physics engine. But let's, before I start to get in that, I really want to sort of remind everybody where we started off. Last year's journey was all about the creation of the rendering engine that we built in JavaScript. And I just want to sort of take us through that quickly and go through the lessons we learned there quickly so I can get into why did we pick a physics engine second. Does that make sense? And then we'll have lots and lots of demos today. So first and foremost, this is Famous's website. I don't know, how many people have seen Famous's website? Pretty good amount of people. So if anybody wants to go to famo.us, if you go there on a computer, you can use ASDW, you know, first-person shooter, or if you go there on a mobile device, you can use your hands to move through it. And what this is running on is a stock iPad running stock Safari. There's no downloads, there's no plugins, there's no use of WebGL, there is no use of Canvas. And here's one of the kickers: there's no use of CSS3 transform primitives or transition primitives. And what we're looking at here is pure DOM. This is DOM elements floating in space. Each one of these guys that's floating around is simply a div, and the text is text. And yes, in fact, that is the dreaded WebKit box shadow that we see everywhere with transparency. And what this really is just a kitchen sink demo of all the things that you're not supposed to be able to do in HTML5. And so just running through real quick, we know that infinite scroll with momentum is hard for people to do. So this is at 60 frames per second in full 3D, any direction I want. I can also pivot this in 3D space, and we automatically change the model view controller to go into 3D space correctly. And in fact, I can pivot this and do another thing that you're not supposed to be able to do in HTML5, and that is interrupt an animation in mid-flow and transform into another animation without a flicker. So I can throw this in 3D space and then grab it and, of course, move it anywhere I want. The other thing we can do is change from a different view to a different view very, very quickly. And in this example that we have on our website, we have 5 views, each with its different controller. So we have Wall of Fame, we have Helix, we have Sphere, and we have what we call Paraflow, and then we have just to be nice, we have the periodic table of elements itself, each with its own control functions in it. And one of the things that you can see that we can do is touch any of these objects, and you can actually navigate to the objects. And the same code that's rendering this and helping us go to these objects is the exact same code that's taking us to these objects, because we treat everything like a game engine, and we're just doing camera control here. One of the other beautiful things we can do is you can see that we can switch a view into another view and then touch the screen while the view is compiling itself, and we actually capture that and handle the throw elegantly. So I can switch from a sphere to Paraflow, throw it in the middle, and you'll see that I'll recover quite elegantly. So I throw it now, and I recover, and it rebuilds itself on the fly. To be able to do this is all about RequestAnimationFrame. How many people here have messed around with RequestAnimationFrame? Lots? Yeah, the hands were lots less last year. But the idea is the pristine and elegant control of what happens in an animation frame. And the way it kind of works for those who haven't done it before is you request an animation frame, you got to do a bunch of junk in that animation frame, and then on next tick you grab another animation frame, and you got to do a bunch of junk, and you string them together, and that's how you create your frame rate. And the idea is if you can get all the stuff you need to get done in 16.66 flat milliseconds, then you will achieve 60 frames per second. But the thing about RequestAnimationFrame is it expands and it contracts depending on how long it takes the job for you to get done. And so what needs to get done within an animation frame, and what is that loop? Well, the answer is simple. You take parsed DOM, and then WebKit, or whatever the renderer is, then calculates the matrices for the DOM, multiplies the matrices, creates a composite matrix, throws it into the GPU, and the GPU paints the bitmap. The gnarly piece where WebKit falls down on is reading the parsed DOM and creating the matrices, multiplying the matrices, and winding up at a composite matrices. WebKit is designed to do that, optimized for a document. And so no wonder when we try to build apps with it, WebKit kind of falls apart because it's not optimized to build an app. So what we did in the JS render is we built an optimized JS render that's optimized to handle apps or things that we do in Appy World. And the beauty of this is we've optimized this so well. This is now 8 months old or so. You get 16.66 milliseconds per animation frame to hit 60 frames per second. This on an iPad is running around 6 milliseconds is all we need, and we're just hanging out for the rest of it. On a computer, it's around 1 or 2 milliseconds. On a television set, it's around 3 to 4 milliseconds. And the other thing is we have very low standard deviation of variability in each frame. Usually 1 millisecond or less deviation in how long it takes us to compute this, each animation frame. So what we get is extremely stable frame rates that are extremely predictable and rock solid, which is the exact opposite of what you get if you decide to use WebKit as your renderer. And the beauty is our render just appends itself as a JS library. There's no download, there's no install. You just call our library, it takes over, appends itself to WebKit, and then just reinserts itself back into the flow of WebKit at the right point just before the GPU. If you open up the DOM here and inspect, which I highly recommend everybody does, you'll just see that these are just div elements. And you'll see us applying the composited matrices to each of the div elements that we're computing in JavaScript. And the odd thing is this can happen 14 times faster in JavaScript than the compiled C code on Chrome. It's simply a fact of using the right tool for the right job. It took us 2 years to get to the point where we were able to build this. But once we got here, it was a pretty exciting standpoint for us because we had all these milliseconds left over each animation frame. Right? So we're thinking to ourselves, well, what do we do with that extra time? So we're like, hey, I got an idea. Let's go do a physics engine. You know, we were gluttons for punishment before when we built our rendering engine. And you know, we told our investors, we said, we want to build a physics engine. We think it's fundamental. Trust us. Give us a ton of money to do it. And we were able to raise a huge round of financing to help us go after something that was sort of another level of complexity beyond a rendering engine. And then we wanted to hook the two together. And so what today is about is the journey that we went on trying to first find a third-party library to do our physics engine, and then ultimately realizing we had to build it for ourselves from scratch, and the lessons we learned along the way. And my hope is that we just teach you all these lessons so that you don't make the long and painful mistakes we did, and then so you can move a little bit faster. The thing is, when we went to start our physics engine, like everything else in HTML5, we were excited. We were like, this is going to be cool. I can't wait to do a physics engine. You guys, how many here have seen demos of physics engines? They're super cool, right? Like, I actually cordon off time at night just to play with these things. And, you know, we head into this, and we're like, hell's bells. We're going to find the coolest physics engine on Earth, and that's me and Mark with our team trying to go. I don't know who the little kid is. We've been trying to figure it out, and we're like, we find a library, right? We're like, oh my God, this is cool. I can't wait to play it. We start playing with it, and we're like, this is the coolest thing since sliced bread. This is going to be it. And then we're like, wait a minute, something's wrong with this library. I can't quite put this to words, but something's wrong with this library. And then we look deeper as we try to actually build something with the physics library, and we get to the point where we're like, shit, it only works with WebGL on Canvas. We're DOMies. I want to live in a Webby world. I don't want to live in a WebGL on Canvas world only. I love those worlds, but I want to start with DOM and then go to the easier worlds later. So we're like, it needs to work with DOM. We can't use it. So we're bummed. But like anybody in the HTML5 industry, we're like, hey, we're not giving up, back out on the trail, we're looking for another one. We hit another one, we're like, oh my God, we're so excited. We're like, this one's it. This one's going to be the winner. And we're very excited about it, and then we get into it, we look at the code, and we're like, hey, it works with DOM, that's awesome. And then we're like, wait a minute, wait just a minute. Something's wrong again. And we're like, it only works on computers. It doesn't work with mobile devices. Crap, we are a company that starts with a mobile device first and goes to the easier devices later. And we're like, crap, so this thing isn't built for that. So there we are, we can't use it. And we're like, back out on the trail. We're still going after it. We find another one, and we say, oh my God, a new library. And we're like, all right, clearly, this is the one that's going to be the winner. But then we get into it, and we say, OK, it works on WebGL. It works on Canvas. It works on DOM. It works on mobile devices. But then we're like, but something's wrong about it, because we look inside the code, and we're like, is this really what it seems? Because we look at the code, and we say, are we happy with the way this was architected? Does it follow the rules we learned when we built the rendering engine? We learned a lot when we built that initial rendering engine. And so we get into the code, and invariably, whenever we looked under the code of the hood of the code, we're like, wait a minute, when we invite a third-party library to be part of our stack, it's like inviting a new family member. And we're like, do we want this type of family member coming to our house? And we're like, this feels really weird. And the issue is that any third-party library we ever looked at always breaks one of the 3 commandments. So these are our 3 biggest lessons learned. And if you nail these 3, you get 60 frames per second, period. And that is 1, you must have pristine and utter control over DOM reflow. If you ever don't manage DOM reflow correctly, you're dead right off the bat. That's the simple, dimple one. The second one is you must pristinely control the event loop. You must not have any third-party libraries, or any libraries for that matter, fighting over the event loop, because all you need is one collision and you're dead. And the third is you must have a deep understanding of how texture caching works in the GPU, and how not to accidentally set the dirty flag on a texture cache. If you can get those 3 things right and nailed pristinely, you will get 60 frames per second. If you miss just one of them, just a little bit of one of them, you're dead, and what you get is inconsistent frame rates. So we were like, you know, a big wham. No library. So we're like, well, clearly, let's build it. And we said, so what are the core fundamental principles of what a physics engine needs to have in order to really work well in HTML5 at 60 frames per second on a mobile device controlling DOM? And the answer is the code must abide. And it must abide by those 3 rules I just talked about. It must use the request animation loop, or it just won't work. It must do DOM first and consider DOM first and do the easier things later. It must do mobile first, do the easier devices later. It must be 3D by default, so you can do the easier 2D stuff easy. And it must have unlimited capabilities in the sense that if you're a senior engineer and you want to directly tap the engines and build really crazy stuff, you must be able to have direct access to the engines. But if you're a junior developer and you want to get stuff done, you must be able to access higher level abstracted code that looks a lot more like jQuery or syntactical sugar so that it can help you build things. And even a layer above that, we wanted to be able to build things that designers could use so that designers could come in and actually be much more efficient than they currently are in HTML5. And we have a demo coming up that really talks a lot about that. So first and foremost, can you do physics at 60 frames per second, controlling DOM on a mobile device? Well, yes, you can. And so let's look at a simple demo. Okay. Okay, so we purposely made this look a lot like existing physics demos out there. Most physics demos you see are abstracted, like balls flying around, and you never think of it in terms of like, how is this useful? You only think of it in terms of like, oh my God, this is cool. And that's about it. What's unique about this is, again, stock iPad, stock Safari, no plugins, no installs, no WebGL, no Canvas, no CSS3 transition primitives. This is just physics and DOM. Physics and DOM. And what I'm going to do is some very simple, basic things that all physics engine demos do. Number one, create a gravity well and pull everything to your finger. I have no idea why this is important, but it is. And so here I am pulling all these objects around, and I'm able to just suck them into my finger here as I go through. And if you see the little gray area, that's the sucking vortex of awesomeness that we have there. If you have, pull, by default, you have to have push. I don't know why either, but here we go. Get out of my way, everybody. Here I come. And so you can create any of these vector fields, bring it back to pull for a second. I can do group by, so maybe this is starting to get a little bit more useful, so I'll group by color, and I'll pull these little doodads around, and then maybe I'll grab two of them at the same time and grab them around. And then maybe you're thinking, maybe this can be useful. Would I do this with like Pinterest, or would I do this with Twitter? I have no clue. But it's super cool, and it's in DOM, which is what's important. I can redistribute this in any shape I want. So remember in the periodic table demo, each of those shapes, we had 5 shapes that we developed in space in our 3D rendering engine. Well, this is a vector field shape. Okay? So think of if we changed over the periodic table, which has all of those different shapes, which are DOM shapes, surface shapes. We can create shapes in surfaces now or in vector fields. So instead of having things hard code to a shape, we can actually just have them flow in through physics into a vector field. So those types of shape-shifting things are going to be fundamental to our future. And I know this is like super abstract, but again, I urge you guys to go out there and like grab like an iPad 1 or an iPad 2 or some just standard iPad or a Galaxy and go to all these physics demos and try this and put it on the DOM mode and see if it's fast. There is a couple of them out there that are okay speeds if you try it on an iPad 4, but they eventually break one of the commandments, and that's what kind of bummed us out at the end of the day. So this is just sort of a discrete exemplar set. We're going to make this available for everybody to play with and inspect in the future. And it's going to be part of our Hello World series. When you learn how to code the physics engine, everyone in the world will be building this little app. But that doesn't solve everything, because a lot of people are like, why physics in the first place? A lot of people question why using it. A lot of people say, hey, I just custom code all my transforms, and I am a badass programmer, and I can code any transform. You give me a bounce that you're doing in physics, I can model it on my own. No need to do this. And they say, physics is one of those things that seemed like a good idea when you tried it, but once you get into it, it kind of turns out to be a bad idea. And other people come into it, and they're like, it's just frickin' overkill. You don't need it at all. But I would like to say that I don't think that that's true anymore. I think it used to be true, but I don't think any longer it's true. And there's a guy who changed everything. When Steve Jobs came out with the iPhone and the iPad, and he came up with the very concept of the native app, we entered what I call the interface race. Interfaces suddenly became much more complex rapidly. And so I would say if you're simply doing sort of a jQuery mobile sliding drawers sort of interface, you don't need a physics engine. I kind of agree with that. But if you want to win in the marketplace, the interface is now a competitive advantage. Imagine going into a store and you're choosing a phone and you're saying, well, which interface do I like? It now matters. and then you're choosing an app in the App Store, and you could choose 2 apps that do basically the same thing, but one of them has a crushingly beautiful interface, and the other one has a sliding drawers jQuery mobile interface. You're going to choose this one. So now we're in this interface race. An interesting dynamic is happening that hasn't happened before, and that's complexity in interface design. So imagine you have a scale, and at the bottom of the scale is jQuery mobile sort of sliding drawers type of thing, where a human being, good engineer, can build custom animations that use the primitives and sort of get away with it. Now, imagine you go up a level. Well, the complexity expands faster to manage that than the beauty of the animations themselves. And so if you compare a baseline sort of jQuery mobile or Sencha app, you're around here. Then you look at the most popular, beautiful Apple apps. They're way up here in complexity. And what happens is there's a magic bright line somewhere in there, in between those two, where the complexity of managing all the different relationships and interactions between all the animations is such that a human engineer can no longer hard code it in order to manage the complexity. And you break a line somewhere in the middle there where it gets so complex that a machine needs to manage the complexity. And so in the early stages, a human being can abide by the 3 commandments by themselves by coding really good, hard code, solid code. But at some point, it will get to the point where it's so complex, no matter how smart you are, no matter how good a coder you are, you can no longer manage it anymore, and your code flies apart. And so that's what Famous is at the end of the day. It's a machine that manages the complexity of the interaction between things in such a way that we abide by the 3 commandments. That's basically what we are at the end of the day. And what happens is invariably any coder or any development group or any company that gets into building these apps eventually gets to the point where they realize that the hard-coded stuff they're doing is actually reinventing the wheel of physics anyway. And so what would you rather be as an engineer? Know that you have the proper foundational elements built correctly when you start your project, or be 3/4 of the way through it and realize, like, oh shit, like, we got to tear everything out and put a physics engine in. And so what we believe the future is that when people start projects, they're going to start with a surface rendering engine, and they're going to start with a physics engine, because they're going to say to themselves, hey, it's obvious. We want to have a company that builds an interface that competes at this level. And so we already know that that easily crosses the bright line. So we know we need those infrastructure components anyway. So let's start having them right from the beginning. But is it practical? We saw the cement truck, the pink cement truck flying up in the air. Can we see a practical demonstration of why this is important? So this is a big one, mainly because I need to go to portrait mode. So we think that the way design is done is going to change in the future. What we have here is a basic, simple scroll view with some movies on it. This scroll view is different than all other scroll views in that it is controlled by physics, not by transforms, not by hard-coded transforms. So the way we built the scroll view is governed in a completely different way. And you can see here I have a pretty basic scroll view. It's actually set to mimic exactly Apple here. And it looks kind of cool. You know, it's all right. What we think the past is a designer saying, hey, I want to change this a little bit, and they go in and they mod CSS attributes. Last time I spoke, I said CSS3 is an abomination. It should be thrown away, and I still think that. Because when designers go in there, so deciding what the bounce of this should feel like is the domain of the designer, and should be. But going in and modding code that could screw up performance is not a designer's job. That's the engineer's job. And I've always said that CSS3 is an improper abstraction that muddles the world of the designer and the engineer. And so when you have a physics engine attached into these objects, every object now has its own physical attributes. They have mass, they have weight, they have force, they have friction, they have all the sorts of things that you imagine that exist in the physical world. And if you can do that, you can modify the kinematic attributes associated with each of those objects instead of CSS. And that is the appropriate thing. We see a future where there is JS controlling everything, and it spits out DOM, CSS, which are virtually never touched, and kinematic attributes. So when you open up the spec inspector in Famous, you see the DOM elements on the left, and when you click on a DOM element, you get the CSS, and there'll be another tab that has the kinematic attributes of each DOM element that you can change the physical force vectors as you will, kind of like this. So here I am looking at this, and what we've done is surface just a few of the kinematic actors that we're capable of modding. Tightness, grip, bounce, friction, drag, fade, spin, swivel, mass, depth, just some fun things with this. So imagine we have this baseline scroll view here, and I want to show you how quickly we can mod this so that it looks way, way, way different here. So number one, let's say I want to have this have a bounce at the end of it. It's as simple as just reducing this, and now I have nice, sexy bounce. I can make it a little bit tighter. Now I have a little bounce. I can make it looser, loosey-goosey. I can make it go boing. I can make it go back to loosey-goosey. And I can even make myself a clock. And so you get to a point where you have now a proper abstraction between the designer and the engineer. So the engineer is up there modeling tightness, grip, bounce, friction. These are physics things, fun things for an engineer. It's like, ooh, I want to do drag. That's fun. But once drag is modeled, you just surface that kinematic and then hand the iPad to the designer and say, get out of my hair. And the designer's like, good. And the designer then grabs the device, and instead of trying to model this on some other system that isn't the actual element that the customer is using, you just grab the actual iPad or the Galaxy that you're developing for, and you play with the kinematic actors on that device. That's insanely important because the JS engines on each of these devices are a little bit different. Many people have coded a scroll view in JavaScript, and then they play it on an iPad and play it on an Android, and it feels different. And you get this uncanny valley thing happening. So for us, there's no code change. You just go pick up both devices and play with them and change the kinematic attributes until it feels right on both. And then you just profile the device, and you're done. Well, we can go way beyond what I just showed you here. If I take it back to the defaults, I can actually style this thing in 3 dimensions and start adding attributes that have never really been ever added before. So when I throw books like this, I actually think they should plane in 3D space. They should sort of be like, whoa, like, what are you doing? Like, you're throwing me fast. Maybe we want a little bit of a sort of a cover flow animation here. We also maybe want to put things like designers like visuospatial overlays. I don't know if we'll be able to, is it possible to dim the lights at all? Yeah? Okay. I'll do the visual spatial overlay in a minute. But let's say I want to make these guys sort of be affected in space and be affected by my throw. So the harder I throw it, the more these books are going to plane and rotate in 3D space. So here we are now, and I don't know if you can see that. They're now rotating in 3D space. And if I throw it and stop it real quick, you'll see they'll kajiggle and kawiggle in correct physics until they settle. So if I throw this and stop, can you guys see that? And you can see it's clearly trying to copy it because it is real DOM. As well, I can bring the depth forward. So now you see, I don't know if you can see, the middle object is now popping forward in 3D space. So now I have an object where I am now throwing this in 3D space. When I stop it, everything settles in space, and the middle object that's in the middle is popping out more than the other. So if I go slow, nothing goes, the objects don't swivel in 3D space. But if I go fast, they do. These little differences are what matter in interfaces. Imagine adding this up to 1,000 little differences until you get to the point where a consumer looks at an app or an interface and they simply say, I gotta have that. I don't want this old stuff over here. This one just feels so much better. And I can even go so far as to change the attributes of individual objects, like changing the mass of objects and associating it with their popularity. So what I just surfaced here is the ability to say, give, in this case, movies that are more popular, more mass. And what that means is when I throw them and I stop it, the more popular books will take longer to settle because they weigh more. See it? I can also do fun things like add visual spatial overlay. I think it's dark enough now to see it. So if you look here, I'm actually adding a little bit of a light source here to this so that the center object is more highlighted. Everybody see that? So now we get a full effect here where everything is popping appropriately and looks way, way, way different than the original animation. And the idea here is that we see a world where there are these widgets, and the widgets have kinematic actors, and designers go in there, and a brand like ESPN or a brand like Pinterest or a brand like Facebook can create customized branded experiences so that a Facebook scroll view feels like a Facebook scroll view, and a Pinterest scroll view feels like a Pinterest scroll view. And these branded experiences can be essential for consumers to buy devices in the future. Okay, so we talked about simple examples of a simple physics model, and then we also talked about how would these be applied in real world. But as we do with everything, we try to go to the nth degree and come back from that so that everything else is simpler. We always try to do the hardest thing first, and then that way your real world life becomes very, very simple. So I talked about the periodic table being sort of the hello world app that you learn in Famous when you learn the surface rendering engine. But the app that you learn eventually when you learn the physics engine and you combine that with the surface rendering engine, we call Hello Galaxy. And it's a lot of fun because you get to model an actual galaxy with moons and planets and suns and so forth. And we wanted to give you a little bit of a taste of this, but this is an app that everybody in the world will be coding in the future, and you'll be doing this in like just a couple hours. And again, this is stock iPad, stock Safari, no WebGL, no Canvas, no CSS3 transforms, and this is just pure DOM elements rotating around. And this is actually run and governed by physics. We are not custom coding any of these transforms. And this is a good example, a good abstracted example of this would be virtually impossible to build if you were hard coding. This is way above that bright line of capability of any human being trying to manage all the complexity of what's going on here at any given time. We think this is candy compared to what's possible in the future. As we see devices get stronger and stronger GPUs, as we're seeing GPUs capable of doing multi-threaded texturizing, this stuff can actually go way beyond this. And so this is the new Hello Galaxy example and our physics example. We have similar examples that we'll be doing in our gesture engine that I'll be talking about. I hope if Ann offers me to come back to speak again, I hope we'll do the multi-screen engine next time with the gesture touch engine. And in each and every time, we always try to build the impossible first so that we can back off to the reality, and then it becomes easy to do the reality. As always, I welcome any question that you have. Last time we talked about Famous, we didn't know how we were going to share this with the world. And I'm very, very happy to say that we've finally been able to figure out how to make Famous available to developers. And I'm happy to announce that for developers that are building apps and deploying them, it is free, period. So everyone should be able to try this out. We aren't launched yet in beta. And now the bad news. About 28,000 people have signed up for Famous. About 7 people have been allowed in to play with it. We are not lean startup. I do not believe in lean startup. I never have. I think it produces bad engineering. I am much more like Apple. Did someone clap? One clap? A small rising. I know it's super popular to do lean startup, but I'm very passionate when you're creating a platform like this. It needs to be rock solid for you guys. So if anybody's adopting a new platform, you are investing your time and your life in that platform, and I respect that deeply because I am the engineer that is using this, and I feel that strongly. So we're not going to release it until we're good and ready. And what good and ready means is that our business model is set and it's free for you guys. We are well funded. We're going to be around for a while. We're properly staffed. We have great documentation, great tutorials, great examples. That things are built so a senior engineer can do any damn thing that they want, but a junior engineer can use it too. And all of this stuff takes time. And so we are turtles, we are not hares. But look how much we've been able to do by not using the lean startup style in just 6 months. So if we slowly progress and make wise decisions and architect things elegantly from the beginning, I believe we change the world to a little bit better place and a little bit away from spaghetti code. And I'm ultra passionate about that, but it means we have to wait for this platform to be ready. Please sign up. It helps our investors know that everybody cares about this sort of stuff. It's scary to say that we're going to be giving this away for free. And the next big decision that we hopefully get to make between now and the next time we talk is this going to be source obfuscated, source viewable, or open source? And we've been really thinking about that deeply. We've been thinking about it for years, and we still haven't decided. I will tell you that our leaning is open source, but I will tell you the shit's complicated. It's really tough to do. We have to somehow create a business and make money to pay people's salaries at the same time. But our definite leaning is free for everybody that's trying to build these apps and change the world. And if we can get there, we would love to be at least source viewable. And we hope that we can create an environment where all of you guys can create your own 3D templates in Famous. And we're going to create a marketplace where you can create those and perhaps even sell those yourself. So you guys can create a mini business in and of yourself on this. We are different than most companies in the Valley. I feel like I am fighting a tide against lean startup and trying to vote for elegant engineering. And I know it's hard to wait for things like this that are going to be free and seem to be super cool. I hope we have your patience. I hope we've maybe walked a step together down the journey towards making HTML5 a whole lot better than native. Thank you very much. If we have time for questions, or if we do, this is my co-founder, Mark. So Mark is the, Mark and I have done this mostly together, but Mark is my co-founder, my phenom, my friend, and he is the inventor of most of this and deserves most of your attention today. If we have any questions, we're happy to answer. Bring it.
All right. I appreciate your comments on Lean Startup. Our company's Lean Startup. Extremely difficult to get quality engineering done, and we're a robotics company, so I can tell you it's a real challenge.
Team of 3 now.
Yeah, I do production. So anyway, my question is, it's a general question about how much code you guys think you're doing per day. The general industry standard's 30 lines a day. What do you guys think you guys are doing with this quality code?
1.
I know it's a tough question.
How many lines
a day do you guys think you're doing of code? How many lines you got right now? That's an easy one.
So we're around like 3,000, 4,000 lines of code total. Everything's very modular. It's basically like core Famous engine is 36 files of about 100 lines of code each. The physics engine itself is basically like 10 files of around 100 lines each. So it's all just very modular pieces that we make sure work extremely nicely together that allow for extreme performance things in a very flexible way.
Okay, so my last question is, on the mobile devices, you guys are using single-core ARM processors in general?
It works on single-core ARM processors very well, yeah. Multi-threading is not quite yet necessary to run everything that we've been running so far. So everything's running in the same thread.
400 megahertz or more?
Yeah, that should do the job to like for some of the simpler stuff. Even though for optimal performance on like more complicated interfaces, it's recommended that you have something that's a bit more powerful. But generally speaking, all the demos we have will run at an acceptable frame rate, even back to the iPad 1.
Thank you very much.
Thanks. Left.
Although it's a difficult question to answer, when do you have a time frame on when this library will be released, if you could guess?
When the what will be released?
No, the Famous library will be released.
Oh, the platform?
Yeah.
No. That's my answer.
Thank you.
When we're done.
Yeah, we want to make
when
sure
it's when it's rock solid, period. And I don't know when that is. We're doing really well. We do things like throw people that never have seen the framework in front of it and see if they start crying, which has happened. We are at the point where now we threw somebody new at it the other day, and Tim figured it out.
Oh yeah, basically in about an hour of time, he was able to get like productive with the framework and getting things to fly around, and he was actually able to get very good with it with just a few more hours of usage. So it's like,
we took a designer, mind you, that's a designer first, engineer second, and did I just lose internet?
Yeah, little.
We took a designer that had never seen our framework before, and gave him our code base, and in 2 days, he's the one that built this cover flow example. Oh. We have, well, we lost the screen. Anyway, we can code extremely fast now, so we have done things like, just for fun, we took a mobile device that's a popular one out there and redid its entire interface for, not its entire interface, a good section of its interface, and we did it in 2 days. We can code really fast now. So we want to code really fast, really elegantly, and allow anyone for it to be very approachable. So one of the things we're working on is, and you guys can talk, there's 2 more of us here. Parm, if you raise your hand. Parm helped create Flash and is now with us. And also Justin is with us. They can help answer questions too. Justin was a producer, a key producer for Halo, the game, #1 game in the world. We can all answer all these questions, but I answer questions very longly, and I probably should be more concise here.
Thank you.
Yeah, thanks. Right side.
Hello again. So what is, forgive me if I missed you mentioning this before, what is the plan for Android support?
It is supported on Android. It is now. I could have brought a Samsung and shown this.
How far back in Android land?
Oh, prior to Jelly Bean, we started having panic attacks. Prior to Ice Cream Sandwich, we pass out and die. Is that about right, Mark?
Yeah, so these days, Android runs very well. It's supported. Like, iOS devices are still better supported, but at the end of the day, in the sense that they tend to be a bit more performant, but feature-wise, they're on par. Performance-wise, they're very, very similar. So the gaps are very close. We spent a lot of time with making sure that the peculiarities are solved, and I didn't find it a joy to run on any Android device that was released within the past year, and it still runs acceptably on anything back to like Jelly Bean. Well, not Jelly Bean, but Ice Cream Sandwich, as long as you have like the Chrome browser.
And we run on Firefox, but the one thing we don't run on is Microsoft.
Have you tried Firefox OS yet?
We can't comment on that.
Okay. Thank you.
Sorry. Left.
Yeah, so appreciate the approach. Some of the insights you have kind of indicate maybe a different way of approaching it, or things people should be thinking about now in preparation for when you do have it available. What kind of insights could you give us?
That's a great question. We have a sort of core belief that the gaming industry got it right on the rendering side, and the web industry got it right everywhere else. And so study Unity 3D, study Unreal 4. That's the future. We are simply a shitty version of Unity 3D in some sense. We love gaming thinking on the rendering side, so start learning how to think about surface rendering. Start learning how to think about where the camera is. Start thinking about learning what physics really means, and the way you do that is by studying things like Unreal 4 and Unity 3D.
Thanks.
Forget about DOM. You'll never touch it again. Forget about thinking of rendering in the webby way ever again. It'll be, the gaming world got it right. Mark, did you want to answer that too?
Yeah, so it's really all about using the right tool for the right job, and the gaming world has really been optimized for just rendering like a wide variety of things really nicely, whereas the web world has been optimized for documents. And in the future, as things get more interactive, you'll start to see the features of the gaming world in interfaces. And meanwhile, basically, those things will be integrated with real interfaces with real documents. So eventually, it's like all of us here know very well exactly like what semantic HTML means. That part would still stay for like documents and everything, but like when it comes to interactivity, the gaming world is where it's at. But then you take a look at how well gaming interfaces display and distribute bunches of information, and you'll see it's very primitive over there. There will be a union of those two in the future.
And one other good thing to think about is what will the tools look like to do the development? And he's not on the mic tonight, but ask Param. He will have some deep opinions about the tooling of what this looks like for you guys. Are we on left or right?
Can I ask a follow-up question about that? On the rendering side, you seem very DOM focused. Are you going to do anything with Canvas or WebGL renders?
So we did DOM first, because if we knew if we conquered DOM, the other things would be easy. And we see a vision where we could be sort of the one ring to rule them all. We have not decided to go down that route yet. Lots and lots and lots of people ask us, can your rendering engine render to Canvas? Can it render to WebGL? The answer is, from an abstraction standpoint, from an architectural standpoint, yes, it's abstracted. The way we built the thing is we don't care what we render to. We could hook into, even work on an Xbox and render into DirectX if we wanted to. It's all a choice of what direction we take the company. And what we primarily want to do is build a JavaScript community and then ask our community, where do we want to take this? And sort of have us as a group decide where to go. But we have not chosen to go there yet.
Right. So it's basically if we have like, we have already done DOM for a reason that it provides a certain level of utility when you can use existing DOM and add a lot of interactivity to it, like add a lot of interactivity to real documents, basically existing content-rich things. But the interface can be abstracted to be used for several different outputs. So if, for example, if someone has a holodeck and manages to convince us that it's going to be the next thing and everybody's going to have one, we'll be happy to output to a holodeck if that makes sense. But the abstraction supports that.
And we hope it does.
I was wondering, do you guys support any kind of standard 3D model import, like 3ds, Collada, or anything like that? And the second question is, how do you handle collisions, especially with more complex things?
So standard model support, generally, as of now, not yet. There's already other tools that do that. So your standard, if you needed to like import like a standard model, chances are it doesn't generally have like much content. You're probably better off using like WebGL for something like that. This is really about interactivity.
To answer your question about 3JS, we get a lot of people asking us about 3JS. I put that in the camp of one of those third-party libraries that I went to, and you see, jetpacks flying in the sky, and you think it's great, but then it doesn't abide as much as we want it to. So it will not be you can use 3JS and Famous. You just use Famous. We already have and will have much more than 3JS.
And as far as collisions?
Yeah, collision detections. That is going to be handled by the physics engine. We can't tell you too much about the exact details of how that's going to work, but generally speaking,
it works.
It will
demo it. It's in the physics.
It'll work.
If you guys, come up to us after the questions, all four of us from Famous have demos, and we can show you the collision detection stuff.
Yep.
It's certainly more computationally expensive to do that.
Right.
Okay, the left.
Hi. Are you guys going to have some sort of native wrapper like PhoneGap so you can deploy this in the App Store?
Yeah, great question. We have no opinion whatsoever on wrappers. You may use us in a wrapper if you'd like. We will work with PhoneGap, no problem whatsoever. We think the future is going to be HTML5 in wrappers, and we will just work with whatever wrapper. Yeah, should have said that earlier. So yeah, I mean, a lot of people want to wrap us in PhoneGap or something like that. It's totally fine.
So people ahead of me filed my question down to the following, which is, if I load famo.us in Firefox 19, should I see a static compatibility page?
Right. So we have code in there that detects if it's not Android, or if it's not Chrome or not Safari, then we stop you and send you to videos. We just haven't had time to go back in there. It now works on Firefox as a result of a comment where Mr. Doob tried to copy the periodic table and found an error in Firefox. And then Firefox found the error because of that and then fixed it. So we now work in Firefox, but we haven't gone back and changed that little bit of code that lets you see it in Firefox. That's a good catch. Yeah, so yeah.
Can I still use the get user media and the WebSocket with Famous?
Could you please repeat that question again? Yeah.
There's an HTML5 API that get user media. You can access the camera on the mobile.
Oh,
WebSocket.
Right. So since every scene in Famous is based off of JavaScript, if your browser provides that API, you can use those APIs. We just have a framework that allows you to do lots of interaction with the view and render there. So if you have data that you want to do via WebSockets, go for it. Perfectly compatible with Famous. If you wanted to use some WebRTC, that sort of stuff, also works well with Famous. Does not get in the way. It's as long as you don't use anything, for example, like jQuery mobile scroll view. Or anything that would do exactly part of or fully what Famous is doing, but anything like on the data side, feel free to have at it. And same with like the media sockets and every scene.
So is there any other library I can use with Famous?
Can you use any third-party library, you're saying?
Yeah, some big ones.
Oh.
Not jQuery, but any other.
Right. So it's not going to be 100% the case. I would say that it really depends on the library. So for example, if the library is dependent on a certain way that your document is to be set up, you won't be able to use that library, because the way that Famous gets its flexibility and performance is by having an environment where everything can run nicely and smoothly. If you have a library that interferes with that, that's kind of like driving like a Ferrari on a racetrack that's full of hurdles and with lots of battlegrounds in the middle. You aren't going to be able to just push the full capabilities of everything. Famous is like that too. We just make sure that you can do a lot of stuff performantly and easily, but you can't have any libraries that get in the way. And an unfortunate fact of the truth is a lot of third-party libraries do get in the way.
Right. I would put it in the range of Angular, no way, Backbone, we hope, Meteor, we really hope. That helps.
Thank you.
So demos look great, so thanks for the talk. As far as importing, so I come from a game developer side of the world. We use Unity 3D, which is a fantastic tool. Curious about importing 3D models from tools such as Maya. Do you guys have plans for supporting things like that? And any commentary on that?
So I would say in the long term, maybe, but
I would say no.
Right. Yeah.
I don't believe in going in that direction. That's sort of a religious question. I'd rather create anew and say just drop the old tools, use the new ones. You actually penalize yourself when you do things like that. So I'm more of a pristine, start over again type of a guy, rather than try to integrate with these things that just end up being a clusterfuck. It's just a mess if you go down that route. I know Maya is a great tool. I love it. Param, please talk to Param about it. Param and Venu Venugopal helped create Flash. Venu Venugopal created Maya. he knows more about all this than any of us. My default is no.
Thanks.
Thank you very much. I hope we're useful to you guys. Right.